So the problem here is about how to find the join probability given the conditional probability table for a base net. So suppose we have a base net with F and C connected to A and A connected to H and A connected to N. So the story was, suppose you are far from home and there may be a fire problem F here at home, and there may be a cat problem at home, and both of them may trigger the alarm. Of course, something else may also trigger the alarm, but there are two factors that may trigger the alarm. And when the alarm sounds, it may cause one of your neighbor, one of them is Happy Hogan, the other one is Nick Fury, to call you. So, and of course, they may call you for other reasons as well. So, and then we create a network like this, and we are trying to find a probability of, say, F, C, A, H, N. They are all equal to 1. And we know all the conditional probabilities, for example, A given FC, H given A, and N given A. So the way to do this is use the formula and first factor out F. So this is just this, and everything else given F. And then the next thing to do is to factor out the next one, basically C given F, and then the remaining given F and C. A, H, N given F and C. And you can repeat this many times, so you'll get probability of F, probability of C given F, probability of A given F, C, probability of H, let me change the line, probability of H given AFC, and probability of N given AFCH. So then the next thing to do is to see which ones are independent. So first, F, there's only one term, so it's okay. C and F, they are independent because they form this common cause configuration. So these two are independent. So C given F is just C. And A depends on F and C, so we cannot get rid of any of these. And H is independent of F and C because of the causal chain configuration. So for example, F cos A cos H, so F and H are not linked. So they are given A, they are conditionally independent. So when they are conditionally independent and we are given A, so H is independent of F and C. C for the same reason, because if you look at the network, it's C, A, and H. So these are basically conditionally independent because of the causal chain configuration. And the last one, N, for the same reason, F and C are independent. So what about H? So A, H, and N forms this common cause configuration. Here, this one is common effect, and this one is common cause. And these two are causal chain. And for common cause configuration, these two are independent because given the alarm sounded, they are not relevant. The fact that one person called is independent of the other person calling. So these are independent. So it turns out that we have just FC, A given FC, H given A, and N given A. So to summarize, it's basically product over all of them, A, H, and N, of the probability of that one, say let's say it's X given its parents. So that's how to compute the drawing probability given the conditional probability table. These are all the ones stored in the table for this network, and we have all of them. So we just take their product, and then we can get our drawing probability.